Hello, everybody, and welcome back to the next session of our IBM Z-Security Ecosystem series. We're going to talk about database security today. And yeah, my name is Patrick Kempler from IBM. I'm the Z-Stack platform leader for DACH. Germany, Austria, Switzerland, and I'm very happy that I have a great guest today talking with me about database security on IBM zSystems. So please welcome with me Mr. Jürgen Lind from Software AG. Hello, Jürgen, and welcome on stage. Great to have you with us today.
Thank you, Patrick, for this kind introduction. Yeah, you already mentioned it. Database security is the topic of today. And I think actually database security products, or even the databases are not so tangible. And I would like to invite you on a 40-minute journey, actually, to get it more understandable, to get it more tangible. My name is Jürgen Lind, as you already said, Patrick. I'm product manager at Software AG. Software AG is a global software company headquartered in Darmstadt, Germany. And we are supporting our customers on their digital journey, actually. And the area of my responsibility is the Adabas family of products. Adabas is our database system, high performing, and so on and so on. Okay, let's come to the database security here. Database security. Before we talk about database security, I would like to start very outside with the environment, actually, of the environment where we are in. Yeah. And here we can see, generally speaking, we have a trend to more openness than 10 years ago, 20 years ago, both from a technical perspective as well as from an economic perspective. So maybe you can think about browser, for example, browser and World Wide Web. 30 years ago, I think it was 30 years ago when it came up, we transferred only texts. Yeah. Meanwhile, we have whole applications that are browser-based or mobile devices. Today, nearly everyone has got a mobile device with apps on it, either special apps or you can access web browser-based apps. And all of these things have one thing in common. They drive also our business models. Now think about cities or governments that want to get nearer to the citizens with their online portals. Think about mobile banking, for example. Think about mobile workforce supported by specific applications. So all of these things have one thing in common. It's external access to IT resources. And this means there is access to business logic, there is access to data, and most of this data is in the backend systems, and a lot of this data is in databases. Most of it is sensitive. You can think about financial data, for example, healthcare information, personal data, maybe economic secrets of the organization, things like that. So unfortunately, that trend to more openness is accompanied by a less friendly trend, so to speak. It's the trend to increasingly having cyber attacks. 30% of these are ransomware attacks. I think the number is from last year, and it's dramatically increasing the percentage. And the victims are public institutions, hospitals, and all kinds of enterprises, large and small. And it's even used for digital warfare, as we can see in Europe in these days, unfortunately. So if you take a look at it, it's not only coming from outside. 30% of these attacks are from outside, but there's also acts of sabotage. 70% of these attacks are coming from inside, and nearly 90%, so most of them are financially motivated, actually. So it's no wonder that we or the organizations, the governments, the enterprises want to become more secure, because they have to secure the personal rights, they have to fulfill the personal rights, have to secure personal data, and they want to keep their organizational secrets, of course. And this leads to security regulations. This leads to security audits increasingly, actually. And I'm mentioning here some of these regulations and security mandates. You can see it here. I want to pick some of them and talk very briefly about it. So the first is PCI DSS. PCI is from the credit card industry, and of course they want to secure all the payment data. And Sorry for you, database administrators. I know you are long-standing and honorable, but it's said here that a database administrator should not have access to that kind of data. Of course, you need to operate a database, no doubt, but you shouldn't have access to this kind of data. So that's one thing. We have the GDPR in Europe, General Data Protection Regulation. And you may say, oh, what do I care about European law? But the interesting thing here is it protects all European citizens globally. So irrelevant where the geographic location of concrete data processing is, the law secures us European citizens, even if the data is processed in the US or in Brazil or elsewhere. And the principles are very interesting. It's data protection by design and by default. If you cannot ensure that this data protection is there, you are not allowed to process the data. They say you have to encrypt, you have to pseudonymize, you have to anonymize wherever possible. And they are also establishing operational security, but that's not the topic of today. HIPAA, Health Insurance Portability and Accountability Act in the US. It's about healthcare data. Again, here, it should be kept private, of course. SOX, this is a more economic kind of standard or regulation. It's United States federal law, and it's about mandates in practicing financial record keeping and financial record reporting. So you need accuracy and reliability of the corporate financial data here. And this, again, leads to data security and data auditing. FIPS is a standard by the NIST, the National Institute of Standards and Technology, and they are defining, let's say, what is a cryptographically safe algorithm. So they are setting the standards here for cryptography and the respective algorithms. Cloud Security Alliance. This is a nonprofit organization dealing with cloud computing security. An interesting statement here is, if you have an application exposed to the internet that will allow people to make money, it will be probed. And remember the trend to more openness. In the end, we are open. Even if we have backend systems, they are somehow open because they need to be accessed. And the access path is definitely open. And we need to ensure that all this is in a safe manner. Okay, let's switch a bit towards access control and encryption. So if we have access control can be compared to a gate. And if you have access control in place without encryption, then anyone can just walk around the gate. So you already get the point, And encryption without access control is like a fence without a gate. So anyone can just walk straight through and it's no security at all. So I think you already know where it's going to. Only combined, these two measurements create a safe environment. So we need encryption, we need access control, and only combined you can secure the target. And the target in our case is not the ground, but the database actually. So when it's about access control, we have two terms, authentication and authorization. I just want to briefly mention them. Authentication means if we have authenticated someone, that we know the identity of the person. That's the group that is in dark green below. It's in the middle. It's the authenticated people, but their identity is proven. Just that. The grayish people, they are not authenticated, and thus they are especially also not authorized. And then we have two other groups here. They are both authenticated, so we know who they are, but the reddish ones, they are not authorized. We know who they are, but they should not have access to the ground, to the database. And the greenish ones, they are part of the game. They are authenticated. We know who they are, and they are authorized. They can play the ball. Speaking, they can have access to the data. So this is an interesting thing. It's called the defender's dilemma. It basically says, as an attacker, you just need to have one gap, one gap, one hole to get in. But as a defender, as a database administrator, as a software company, you have to close all holes. You have to close all potential gaps. That's the defender's dilemma. Let's switch a bit to auditing. Auditing is about tracking everything, storing and archiving the information, and then later on query it if so needed. And coming back to our original illustration of access control and encryption, we can ask, where is auditing in this illustration? And I would say it's the cameras, for example, filming the gate, or it can be the card reader that is reading all the cards and the log file behind it. Or it may simply be the manually maintained list of the guard of everyone wanting or having access to the ground, actually. That's auditing. So let's shortly take a look at the role of auditing in security. If we have active auditing in place and there was a misbehavior of an employee, let's just imagine, yeah, then we can expose the attack based on evidence. And what is the evidence? The evidence is the logged data. If we logged all access and operations on the database, then we can say, okay, here was something that was not good, actually. But also for the organization, if there has been some misbehavior, some attack, some data leak, yeah, we can reconstruct the actions that had been taken. We can know what resources have been accessed. We can understand the criticality of the data that had been leaked. And we can also ascertain what data had not been leaked. So kind of risk management in case of data leak or misbehavior. But there's also a positive side to it. Yeah. So if an organization or an employee gets wrongly suspected, we can also disprove the suspicion based on evidence, of course. That's another way of looking at it. That's the same in pros, but I want to just go on the first statement here. If an organization has got active auditing in place and communicates it actively, then it can, of course, reduce the number of insight attacks and misbehavior. It's not 100% safety measurement, of course, but it's still very effective, I would say. Okay, coming nearer to database security and talking about encryption. In encryption, we always have two things. We have something that is not encrypted and we have something that is encrypted. The thing that is not encrypted is often called plain text or clear text or unencrypted data, raw data. And then we have a thing that is encrypted. It's called ciphertext and encrypted data. And on the way from the plain text to the ciphertext, we need an encryption key. And if we want to decrypt again, we need a decryption key. So what we are doing here, we are having a big secret and we are turning it into a safe thing if we encrypt it. And we also exchanged a bit the big secret into a small secret. The big secret was the whole thing, the whole data, the whole text, whatever. And the small secret is the key. Think about your house. You don't take the house into your pockets just to be safe, no one gets in. Yeah, you lock the door and just take the key into your pocket. So that's a bit the analogy here. Does anyone know what that is? Actually, and I'm not talking about Pussy Galore from the Goldfinger James Bond here. Of course, I'm talking about the United States Bullion Depository, which is also known as Fort Knox. It holds around the half of the United States gold reserve. So it's if you want to get rich, it's worth thinking about attacking it actually. But maybe you will be disappointed because it's regarded a very strong safe. So what does this Fort Knox, this very strong safe, has got to do with database security? If you use strong encryption, then it compares to a very strong safe. And if you have the combination of the safe, the thing that gets you access to the value behind in the safe, yeah, then that compares to the crypto key, the key used to decrypt the data. So strong encryption is like Fort Knox, and the crypto key, the decryption key, is like the combination of the safe here. So, but what is strong encryption? We have state-of-the-art algorithms. State-of-the-art means advanced encryption standard, for example, very long key length, 256 bit, for example, and that turns our plain text data into very secure data. On the right-hand side, it's expressed how long it would need in years to decrypt it, not to decrypt it, to attack it, yeah, to get access to it. And I can't even express the number of years here. So again, you see, we have turned the big secret of data into a small secret, speaking the key. Let me quickly talk about two different kinds of encryption that play a role in database security. We have symmetric encryption and asymmetric encryption. So symmetric encryption is whenever the key to encrypt and decrypt are the same. Yeah, and symmetric encryption, like shown here, is very fast from an algorithmic time consumption. It's very fast, and because it's very fast, it's suitable for large amount of data, and databases have large amounts of data. So symmetric encryption is used for file and disk encryption, but also for data at rest encryption in databases. And again, the secret is not the ciphered text, the encrypted data, the secret is the key. The second thing we have in database encryption is asymmetric encryption. It's called asymmetric encryption because both keys are different. The key to encrypt and decrypt are different, and it's more time consuming from a computational perspective. So it's only suitable for a small amount of volumes, a small amount of data, and it's used for communication between two parties. What does this have got to do with database security? Think about data in flight. The client remote accessing the database, we somehow need to encrypt the data in flight, and both parties need to encrypt large amounts of data, speaking symmetric encryption, one and the same key. So they have to exchange that key. How is it done? They will have a handshake in the protocol, and that handshake is with asymmetric encryption. So also in database security, we not only deal with symmetric encryption, but also asymmetric encryption when they exchange the secret, the symmetric key. Okay, let's move on. Okay, these keys are called public and private key for some good reasons, but let's move on. The decryption key again is the key, is the secret. Sometimes we have to expose a key to the public. We need to store it. We need to store it on a disk, or it is moved to the cloud, and then we need to wrap or envelope it. So this means encrypting it by a different key. And the original key is called the data encryption key, or DEC in short. And the wrapping key, the envelope, is called the key encryption key, called KEC. And this leads to some consequences, actually. So rotation, for example, of the key encryption key is fairly easy without decrypting or re-encrypting all the data that already had been encrypted with the DEC. Also, a key encryption key can wrap multiple of these data encryption keys. So in the end, there are less keys to safeguard. So keys, yeah, we not only have one key, we have multiple keys, and we somehow need to work on them. So the question is where to store these keys, these crypto keys, and the answer is in the key management system. And if we are on IBM zSystems, we are exploiting the IBM's enterprise key management facility here. You will see that later again. Cryptographic keys have lifetimes. They have a crypto period, and the lifetime is a bit larger because the key had been created, and then even if it's not used anymore, there is a bit of a lifetime behind. But interesting is the crypto period. The crypto period can be split into the encryption period. This is the period where you really encrypt data using that key. And then there's the decryption period. That's the period where you use the key to decrypt the data. Sometimes they begin at the same time, but most likely the decryption period will be much longer. Think about archives or backups that still need to be decrypted later, so you still need to use the key. And the whole lifetime of that key is called the crypto period. And we need to take care. Remember, the keys are the secrets. We need to limit the possible defects. So we may want to limit the amount of data that's protected by a single key. So for example, not use the same key for all your databases. Use the key per database, a different key per database. limit the amount of exposure if a single key is compromised. That's also, if you use different keys, then that's also hold. So it's all, I don't want to go into more detail here, but it's all about limiting, it's all about creating obstacles. And what can be said is the higher the sensitivity of the data, the shorter the lifetime of the crypto key shall be. I'm not a key management expert, but I can refer you to the next session of this wonderful zSecurity series. And we will have Alina Mo from Empalis talking about key management and also identity management in depth early May. I can strongly recommend this. So we are coming nearer and nearer to the database security. When I'm talking to customers or maybe also to our field organization at Software AG, I'm sometimes confronted with the statement, the mainframe is secure. Well, I'm not so sure on that. And if I take a look at the left and the right to my security fellows, I think they are also not so sure. Not because we are uncertain, but because we think the mainframe is not secure per se. We will see that later. Here is another thing. On the left-hand side, we see some hardware, and the man in the middle is saying, in this corner we have firewalls, encryption, antivirus software, etc., etc. And in the other corner, in the red T-shirt, we have Dave, the human factor. So it's all about us humans, actually. Yeah, we can have measurements and measurements. If we don't exploit them, and if we don't implement them, then we have the first human error. And if we have established all of them, then probably we will be socially engineered to get to the keys, actually. So watch out, be careful. Some security guidelines in database security. We also already heard about data in flight security, data at rest encryption. I can only say, remembering the defender's dilemma, close all gaps. Use data in flight encryption, establish access control, use data at rest encryption, use disk encryption. Yeah, establish proper key management, follow the recommendations, for example, by NIST here. There are also recommendations by other countries, by the Federal Agency of Computer Security in Germany, for example. Think about, are your gates wide open or do you have a policy of zero trust? I would suggest to always verify, not trust, yeah, enforce least privilege principles, keep the realms as small as possible, follow separation of duties principles. So again, the question, is the mainframe safe? I would say yes, but just as safe as you implemented the security. So please exploit all available measurements. They are here to be used. So in database security, there is a pyramid. I first saw it from an IBM fellow, actually, and it is showing the levels of database, the different levels of database encryption. And it's important to say that each level is addressing a different kind of threat. So it's not said that if you are in the grayish zone, full disk and tape encryption, that you are safe. No, you are not safe, because full disk and tape encryption is just against the threat of the disk or the tape leaving your organization, leaving your house for whatever reason, either accidentally, by theft, or by purpose, because you just exchanged the disk and the technician took the old disk, or you threw it to the waste paper basket or whatever. Yeah. So this is just this threat. Data set and file encryption is a completely different threat. It's again, it's securing against people having access to the system. And if they are not allowed to see the data, you need to have file and data set encryption in place. Remember the general data protection rule. Remember the healthcare in America. Yeah, you are not allowed to access this data. And of course, coming higher, we have database encryption. This is encryption of data in flight or data in use. And then there's app encryption. We don't deal with that at Software AG. We don't deal with app encryption. We don't deal with full disk encryption, not in a product sense. Yeah. So app encryption is only very, very high level of security, where even the database only gets ciphertext. So let's watch this pyramid from a Software AG perspective to see what products we have in place. If we are talking about access control, we have Adaba subsecurity. If we are talking about database encryption, We have the remote access to the database. This is done by NTR network. It's a TCP/IP based protocol of software AG, and of course that needs to be secured. And we are exploiting the ATTLS, the application transparent transport layer security of IBM here, data in flight security. And we have the file and data set level. This is Adabas encryption for COS, our product that secures the container level or data at rest. And then there's the thing I don't want to talk about, but I need to. It's the ciphering. We do not recommend it, or we explicitly recommend not using it. It's just there for compatibility and maintenance reasons for our customers using it for so long, but we cannot recommend it. It's not state of the art anymore. It used to be, but no longer. So here we have all four in common. Let's switch over it and come back to access control again. I already told you Adabas Self-Security, that's our product to deal with access control when you want to access the Adabas database. And actually it's exploiting the self-security interface. Yeah. So it's a very simple principle. Each incoming call from a client application is validated. Validated against the security server. It can be RUCF by IBM, it can be ACF2 or top secret, and only validated calls get through and have access to the data, either read access or write access or whatever kind of access. Yeah, only validated calls get through. So we are exploiting IBM's system authorization facility, SAF interface, and if it's RUCF behind, then it's also the IBM product RUCF here. So it's tamper-proof, it's fully transparent to the client application. And I want to go a bit into more detail here about what kind of resources can be secured here. It's the Adabas files, better known as tables in SQL databases. It's the Adabas commands, for example, read and write. And it's even the startup of the software, the startup of the servers, be it the Adabas nucleus, be it network nodes, be it replication server, be it audit server, that's all secured. You can secure the execution of Adabas utilities and functions within. And of course, you can secure the online services, the administration user interface with it. So that's Adabas self-security. And we have a strong, in these years, we have a very strong focus on security with our products. So also Adabas self-security is evolving. We have enhanced program control, speaking who can start up, who can exchange libraries or executables. We are securing Adabas event replication, and we also help in more usability to reduce the manual intervention. Whenever the security profiles in RUCF change, we get notified with our October version, and that notification leads to that the cache will be reset. So there's no manual intervention anymore. And further down the road, we will also enhance our behavior for batch use cases, for example, displaying statistics, refreshing the user cache or so. Currently, we need to sign into the online services, and that will be no longer needed. But that's further down the road. And let's get back to encryption. Encryption has two facets, two perspectives. There's the remote access to our databases, meaning data in flight, and there's data in flight encryption. And we have data at rest. So there is data at rest encryption playing a role. For data in flight encryption, we use ATTLS of IBM. For data at rest encryption, we use our product, Adabas encryption for COS. And both of them are there to encrypt the sensitive data to protect it against malicious attacks or data breaches. So let's shortly talk about data in flight. I already said there's the entire network product. It's a TCP/IP-based protocol to remotely access the Adabas databases. And because it's TCP/IP, it can be secured with IBM's ATTLS, the Application Transparent Transport Layer Security. So this encrypts the sensitive data in flight, or sometimes it's also called data in motion. That's data in flight security, encryption of the data in flight. And of course, it's completely transparent. Again, it's transparent to the nucleus of Adabas. It's transparent to the client application. Talking about data at rest encryption, here's a bit more to say. It's encrypting the sensitive data at rest. Yeah. We are leveraging the IBM pervasive encryption here. We already talked about ATTLS. We already talked about RACF. And this time there is coming enterprise key management into play. Integrated cryptographic service facility is coming into play for the cryptographic algorithms. And we have even hardware assist. It's an out-of-the-box solution. It's completely transparent to the client application, and it's even transparent if we take a zoom in. It's even transparent to the Adabas nucleus actually, because it all happens in the input-output layer of the database. And of course, this Adabas database encryption complements disk and dataset encryption, and it also complements data in flight encryption and access control. So now we are going a bit deeper. I already said it's transparent to the nucleus. So the data in use, speaking the data in memory, is not encrypted. Yeah, it's in plain text there, so Adabas can work with the data. But any read or write access has encryption in place. So we need to encrypt the data while writing down to disk, and we need to decrypt again while reading from disk. And all this is done via a specific API IBM provided to us. Because we are using very low-level I/O APIs, we need to call special APIs here to be able to encrypt and decrypt the data sets of the Adabas database. So the actual I/O is not done by our Adabas nucleus. The actual I/O is done by the IBM input-output system, by the ZOS input-output system. Let's zoom in a bit more to have a better understanding that the level of encryption is per data set. So you can pick and choose which data sets do you want to encrypt, which are not encrypted. But again, whether you encrypt them or not, it's completely transparent to the Adabas nucleus, and it's completely transparent to any utilities having to work with these data sets. Anything else to say? Yeah, maybe just about creation of encryption of encrypted databases or encrypted data sets. We suggest the method of ADASAF, which translates to backup and restore for the audience here. There are other methods. We can also load and unload, or reorganize, reorder, or we can format the disks. Yeah, that also leads to encrypted databases if the data set is there to be encrypted. But our way is to recommend backup and restore, even if the other jobs also will do actually. Anything else to say here? It's transparent to utilities. It's transparent to the nucleus. And of course, it's transparent to the client. We fully exploit IBM's pervasive encryption here. So, and also the key management, yeah. Encryption always has to do with keys. We already talked about that. And the keys are fully organized in the enterprise key management by IBM here. So we are not involved. Our Adabas software is not involved in the key management. I don't want to go into detail here. These are just the minimal versions, the prerequisites that are there to be able to secure your databases. And of course, you always can have higher versions of it. The higher, the better. That's it. Okay. I want to provide you with one customer example. I find that example really amazing. We have an organization here that was running out of support with both their ZOS versions as well as their Adabas versions and Adabas tooling versions around. They were out of support. And then they had to migrate to an outsourced mainframe environment. And you can imagine, yeah, outsourcing means the database is somewhere else. And of course, you need to fulfill security requirements, security mandates here. And in just 3.5 months, they managed to upgrade the COS version. They upgraded the Adabas version. They established ATTLS, the data in flight security. They brought in the Adabas sub-security for access control. They established the Adabas encryption for COS, and all this just in 3.5 months. Really amazing. And maybe that's also because of the design of the product, because if you want to have Adabas encryption for COS in place, actually, it's just a license key to make known to the nucleus, all the algorithms that are needed are either in IBM's pervasive encryption already in place in the system or within the Adabas nucleus. And you just have to apply the license key to make it run, to make it secure, to make it encrypted. So let's talk a bit about Adabas auditing again. Our product here is Adabas auditing for COS. Remember, we are here to track and store and archive and query and so on. I think Roy Boxwell already told in the broad about auditing, so I will make it very brief here. Our product database for database auditing is Adabas auditing for COS. It's to track every operation against the database and to be able to query it later. It's a product we developed together with our partner zSystems in Berlin. And important here, I would say, is that we really track all database operations. It's not only read or write access. We also trace, for example, transactional braces and so on and so on. So each command reaching the database is logged. And of course, it's for high volume of data. It's high performant as well as our encryption, also high performing and suiting the needs of auditors, security officers, and DBAs. Having a short architectural high-level picture here, you can see on the left-hand side in a bit more dark. This is the Adabas system, so to speak, and it's implemented in a way that the logging data, the audit data, is leaving the Adabas nucleus as fast as can be to keep the high-performing database in our production environments. And all the rest is done by the audit servers and the storage and archiving system. And once that is done, you can create filters and queries and watch it and query it from a nice browser-based GUI. So that's Adabas auditing for COS together with our partner zSystems in Berlin. I'm just watching the time. I'm fine with the time. So I'm reaching the end of my presentation anyway. If you remember what I said during this journey, I would say don't trust, close all your gaps, exploit all the available security measurements that are there. Our products are here to really protect your sensitive data in the Adabas databases. Yeah, we are full leveraging IBM's pervasive encryption. So we have state-of-the-art cryptographic support here. If you use our products, there is no application changes whatsoever. It's fully transparent to the application. And as we saw in some cases, it's even transparent to the Adabas nucleus itself. Be sure you can fulfill your audit and compliance regulations with these products around database security, about Adabas security. And as already said, we fully exploit the IBM pervasive encryption that's already there. So thank you very much for your attention. Having said this, I hand over back to you, Patrick.
Yes, great. Thanks, Jürgen. So very, very interesting presentation and very good to follow why it is important, yeah, why the aspect database security is very important. And when I think back, I started as DB2 technical sales. So today, two of my favorite worlds, security and database, are combined. So thank you very much for that. And you talked about database security on IBM zSystems, but why do you think is IBM zSystems the best fit for clients' critical data in these times or at any time?
Yeah, actually, I have two perspectives on that. I have the client or customer perspective, but I'm also a product manager, and also as a product manager, I have a perspective. Actually, it's already there. Now we have the cryptographic algorithms there, we have RAG-F there, we have the ATTLS there. So it means less effort for us, actually. If everything's already there, of course, we have to adapt our software to use it, but we can exploit it. That's the perspective of me as a product manager. For our customers, for our clients, actually, I would say if all these things are there in the system and they are there only once, yeah, then they are same across all the software, across all the utilities that are there. It's all the same level, all the same set of security measurements, meaning it's less to maintain. And of course, you can rely on that. You can rely on the cryptographic algorithms and such. Maybe there is the counter argument, there is a single point of failure then. But imagine what it means, what it would mean if you have 20 different systems, 20 different softwares, and you need to keep them in a secure way whenever there is a vulnerability patch or fix, a security fix or patch out there. Yeah. Also, then, if you have this, you just install it as soon as it is out, the security patch or security fix, and then you are done for all your systems. You don't struggle. And actually, if there is a fix, yeah, I would recommend to apply it as soon as possible. That's a basic recommendation in computer security. Apply it as soon as possible, because when it's there, the gap is known to the attackers. So please fix it. And if you only have to fix one gap, you are done. So less stress for the administrators out there.
Yeah, great. Definitely true, and I totally agree. Yeah, okay, sounds very good. So let me have a look. Is there any question from the crowd at the moment? I don't. There is one. How can I try Adabas as sample databases?
Okay, I'm not sure what this question is precisely, actually, but of course we have test contracts. If you want to test Adabas, we can have established test contracts. You just need to reach out to the nearest sales organization, and they will manage it for or with you.
Okay. Yes, sounds good. So everybody nearly could test if he wants. Just needs to reach out to you, and you make everything else from a contractual or test contract point of view. Yeah.
Sure.
Okay. Great. Thanks. I do not have any other question in the pipeline. So to summarize, it's very important. I understood it's very important to secure the databases, even on a very secure machine. And this is another puzzle piece, so to say, in our series, right? So we heard about network security, audits, and now the database security, another very important piece for the full picture. So thank you very much, Jürgen, for the insights and the details you shared with us. So
you're very welcome, Patrick. You're very welcome.
Thanks. So out to the crowd out there, if there's any question afterwards, please do not hesitate to contact either Jörg or myself on the known social media channels or via email or phone or something like that. And I would like to make you aware of our next session. Jürgen already mentioned we will talk about identity and key management, and this will happen next week on the 5th of May, and we will continue with the series in May with 2 additional very interesting sessions. And in the meantime, there was no additional questions. So once again, thank you very much to you, Jürgen. Thank you very much to the crowd for watching us. And I'd be happy to welcome you back next week. Thank you very much and goodbye.
My pleasure. Thank you.